It began as a faint whisper along the edge of the heliosphere, a cold intruder drifting through the deep black quiet between the stars. Before its name became a headline, before observatories turned their mirrors toward it, before the scientists exchanged unsettled glances. iAtlas existed only as a dim pulse in the data stream, a moving point that did not yet know it had been seen. It carried no heralds, no companion bodies, no gravitational entourage. It came alone, passing through the interstellar dark with the silence of something that had already travelled too far to remember its origins. And in that silence, long before anyone understood what they were looking at, the mystery had already begun. For thousands of years, humanity stared outward with myth and wonder, imagining omens descending from the heavens, fiery messengers, wandering spirits, ghostly streaks of ice and dust. Yet none of those stories prepared the world for this visitor. It was not the brilliance of a comet or the majesty of a passing planet. It was not even the drama of an asteroid's metallic gleam. 3. iAtlas arrived not as a spectacle, but as an unease like a breath drawn sharply in the dark. It slid across the solar system's outer threshold with a velocity that betrayed its interstellar past, and with a composure that resembled neither a loose pile of old cosmic rubble nor the fragile frost of a wandering snowball from the Oort cloud. Its presence felt deliberate, as if it had chosen its route with patience. The early telescopic detections showed something odd even before the deeper anomalies revealed themselves: a faint luminosity ahead of schedule, a subtle shimmer that violated the simple geometry of sunlight striking an icy surface. The coma seemed to be forming earlier than physics allowed, long before scientists gave voice to their suspicions, long before the public heard the name 3 iAtlas. For the first time, there was already a ripple of tension in the data. These were not the bright explosive flares of a volatile object waking from slumber. These were controlled expansions, almost reluctant, like the glow of a lantern, slowly unshuttered in the dark. Astronomers tried to explain it away in those first nights: instrumental error, calibration drift, background noise. But the growing pulse of brightness kept returning, each time more insistent, each time harder to ignore. The visitor was not simply waking, it was revealing itself in stages. And in its wake, something old stirred within human imagination, the ancient instinct that not all lights in the sky are merely stones wrapped in frost. It travelled with a steadiness that defied the jagged histories of natural bodies. Most comets carry scars, fractures from ancient collisions, uneven rotations shaped by millennia of wandering surfaces torn by thermal stress. But this object moved like a single unified mass, untouched by the violence of creation. Even its path, graceful, smooth, precise, suggested a past shaped by forces stronger, colder, and far more ordered than those known in the planetary nurseries where comets are born. If 1A, Oumuamua, had been the first whisper of an interstellar stranger, and 2I Borisov the first true comet known to hail from beyond the sun's domain, then 3 iAtlas arrived as something else entirely, a question carved into the void, a riddle carried across unimaginable gulfs of time. In the earliest hours of analysis, scientists felt the tension that comes when familiar models begin to fray. The brightness curve did not match standard sublimation physics. The rotation rate, barely measurable, then hinted at an unusual steadiness. And the coma, already forming, already spreading, behaved as if influenced by something more than sunlight alone. It was as though the object had prepared for its approach long before entering the solar system, as though the heat from our star was only the final act in a sequence that began in some forgotten corner of the galaxy. But the world had not yet heard the words that would ignite global fascination. That moment lay ahead, tucked inside a simple statement that no one expected from the man who delivered it. For now, all that existed was the growing sense of unease around a cold, silent wanderer, whose nature felt too composed, too measured, too precise. Something about it resisted every attempt to label it as ordinary. Something about its presence asked questions that science was not yet willing to confront. Even before the first images were sharpened, before infrared scans painted their strange maps, before the jets revealed their impossible patterns. Atlas emanated a quiet pressure, as if the universe had lifted a corner of its veil and invited humanity to look closer, to consider anew how little it understood of the dark between the stars. Observatories began submitting preliminary reports. Amateur astronomers joined in tracking the object's approach night after night. Data poured through global networks, aligning into a picture that seemed to whisper a single unsettling truth. This visitor was older than the solar system, older than the planets, older than the sunlit structures humanity knew. And yet, despite its ancient wandering, it showed no signs of fragility, no fractures, no debris field trailing behind it. It was intact, entire, preserved. That preservation alone carried implications most scientists quietly avoided. Natural things erode, ancient things fall apart, but this object, this interstellar traveller, carried its age like a sealed container unmarred by cosmic time. In its motion, an emerging glow. 3. Atlas felt like something waiting to be understood, as though its journey across the galaxy had a destination after all. Its silence was not the silence of emptiness, but the silence before revelation. And in that silence, the first wonder blossomed into the first fear. Perhaps this was not simply an object passing through. Perhaps it was something passing back, something returning. And somewhere within the polished hallways of NASA, within the quiet analytics rooms where the first fragments of its behavior were modeled, one scientist, the one who had spent a lifetime shepherding missions, solving anomalies and guiding teams through cosmic puzzles, felt the tremor of recognition. He saw in 3i Atlas not a comet, not a relic, but a pattern that should not exist, a pattern that would soon ignite the words heard across the world. This object is not behaving like anything natural. And from that sentence, whispered first in a controlled room meeting and later spoken publicly with steady resolve, the mystery of 3i Atlas began its long descent into the heart of human curiosity, carrying with it the quiet, growing fear that the cosmos had finally sent humanity a message it was not prepared to read. Discovery always begins as a flicker, an unexpected dot, a deviation in the noise, a faint refusal to behave as the universe normally instructs its wandering bodies to behave. For 3i Atlas, that moment unfolded quietly inside the automated pipelines of survey telescopes designed to scour the sky for transient motion. The Atlas survey in Hawaii, engineered to protect Earth by identifying hazardous objects, never sought interstellar visitors. It watched the heavens for threats, not mysteries. Yet on that night, its wide-field eyes captured a signal that would pass through the first layers of processing with the subtle insistence of something determined to be noticed. It appeared as a slow-moving blur against the deeper dark, too fast to be a classical comet from the Oort cloud, too cold to be a fragment of a broken asteroid, too early in its brightening to fit any natural curve. Astronomers trained to pass motion through instinct as much as mathematics recognized the strangeness in its speed immediately. The object was inbound at a trajectory that pierced the solar system on a hyperbolic arc, a signature of interstellar origin. This alone would have been enough to stir excitement. Interstellar bodies are rare, and the cosmos did not offer many opportunities to study relics born beneath foreign suns. But 3i Atlas did not just pass the threshold of interest, it disturbed it. In the first 48 hours after its detection, observatories across the world began triangulating its motion. Data from the Mount Lemmon survey confirmed its hyperbolic excess velocity. Instruments in Chile refined its projected path. Amateur astronomers uploaded early images, each frame a ghostly smear of an object already refusing classification. It was brighter than it should have been. It held a coma long before expected, and its velocity profile suggested a mass distribution that did not align with any known cometary archetype. The naming convention followed quickly. Third interstellar object, Atlas for the survey that found it, a designation rooted in the mundane bureaucracy of astronomy, unfit for an object that had already begun rewriting expectations. In those early days, astronomers tried to place it within the context of its predecessors. Oumuamua had been enigmatic, tumbling in a strange rotation, and accelerating subtly without visible outgassing. Borisov had been comforting in its normality, a classic comet, albeit one born far across the galaxy. Each had taught humanity something new about the diversity of interstellar debris. But 3i Atlas refused to be down to comparison. Its coma grew too early. Its path resisted minor perturbations, and its initial colour readings suggested a chemistry more layered and complex than Borisov's simple ice and carbon dust. The earliest spectroscopy hinted at carbon dioxide, cyanogen, and traces of metallic compounds that did not cleanly match expected ratios. These were not definitive signals, calibration artifacts were still possible, but the unease they inspired lingered. By the end of its first week of observation, the scientific community recognized that 3i Atlas was going to be studied relentlessly. Proposals for telescope time filled inboxes. Automated sky surveys updated their tracking algorithms to lock onto its movement. Even missions designed for entirely different purposes briefly pivoted their instruments to capture additional data. Yet the moment that changed everything came not from the object itself, but from the humans watching it. At NASA headquarters, where multi-instrument analyses are collated into unified models, The early behavioral patterns triggered a review meeting. Data scientists, dynamicists, chemists, and mission specialists assembled in a quiet conference room. The object's trajectory was displayed on a wall-sized projection. Preliminary light curves glowed beside it, small rising arcs that refused to align with the expected thermal profiles of an object still far from solar heating. It was during this meeting that the first genuine concern emerged. The comet's expansion rate seen across independent observatories was too coherent. Not too strong, not too chaotic, not too fast, but too coordinated. Almost as if the outgassing was not random sublimation, but the product of deeper structural conditions responding in unison. A senior astronomer suggested an internal thermal wave. Another proposed volatile ices with unusually low activation temperatures. Others mentioned surface fractures releasing gases from a deeper reservoir. The tone remained cautious. The universe was full of surprises. New chemistry was always possible, but one participant in the room remained silent longer than the rest, a man whose experience granted him an instinct for anomalies. His training had been shaped by decades of studying mission data, by life-or-death decisions inside crude spaceflight programs, by the disciplined intuition required of someone who once held the responsibility of chief scientist for NASA. Dr. Gregory Rogers listened to the debate. He studied the projected curves, and when he finally spoke, the room grew quiet not because of the authority of his former position, but because of the unease in his voice. "The brightening is not consistent," he said softly, with any form of natural early outgassing. Silence followed. It was not the words themselves that chilled the room, it was the certainty beneath them. Rogers had spent a career identifying patterns in data. He had solved anomalies that seemed unsolvable. When he said something was wrong, people listened. He requested additional spectral data. He asked for comparisons to non-gravitational acceleration models. He requested thermal simulations beyond the standard expectations for cometary activity. And then, in a moment that would later echo across the global scientific community, he leaned back and murmured something that only a few in the room heard clearly. "It's behaving as if something inside it is coordinated." The remark was not official. It did not appear in mission logs. But it marked the quiet beginning of the narrative that would follow the object for the rest of its journey. An idea had been planted. Not a sensational claim, not a declaration of unknown intelligence, but the subtle destabilizing realization that nature does not often organize itself so neatly at such low temperatures and such great distances. And as observatories collected more data as the early coma thickened, and the faint rotations revealed their rhythmic signature, the scientific community began to sense that this was not simply another passing visitor from another star. Something was unfolding layer by layer, signal by signal, and each new observation only deepened the mystery. Before long, the world would hear the bombshell. But in these early days, the discovery was still quiet, still fragile, still contained within the minds of those first scientists who sensed that 3i Atlas was not simply unusual, it was unprecedented, and the universe had only just begun to unveil its secrets. Long before the public heard his words quoted across newsfeeds, forums, and late-night documentaries, Dr. Gregory Rogers stood at the intersection of caution and revelation. His career had been built on identifying the faint tremors that precede scientific upheaval, those quiet deviations that warn of a deeper truth beneath familiar models. As NASA's former chief scientist, he had guided missions that probed the moon's ancient shadows, the fractured light around Saturn's rings, and the thin frost-lined plains of Mars. He had seen anomalies come and go. He had watched countless claims dissolve under rigorous data. He had built an instinct sharpened by decades of confronting the unknown, with discipline, not speculation. So when he spoke publicly about 3i Atlas, the world listened. The moment took place not in a dramatic press conference, nor in a sensational interview, but in a measured, almost reluctant statement delivered during a scientific roundtable. His voice was calm, steady, clinical, yet edged with something unmistakable, the weight of a truth that he knew would be difficult for others to accept. "The object is displaying a pattern of behavior," he said, "that does not correspond to any cometary model currently recognized by the scientific community." It was a simple sentence. It carried no claims of extraterrestrial engineering, no hint of fantastical interpretation. But the impact was immediate. Scientists who had followed the early data understood the gravity of such a statement. Rogers was not prone to exaggeration. He did not chase theories. He did not stir controversy. If he went public with an anomaly, it was because the anomaly refused to be ignored. Within hours, discussions erupted across observatories. His remarks were dissected, replayed, scrutinized word by word. What exactly did he mean by pattern? Why describe the object's behavior as coordinated? And why, most troublingly, did he choose to speak at all, having spent a career navigating sensitive discoveries with quiet reserve. In the days that followed, Rogers clarified his position, expanding on the precise features that unsettled him. He discussed the early brightening of the coma far too strong for the object's distance. He pointed to the rotation curve that displayed an almost machine-like stability, and he mentioned with particular emphasis the jets that seemed to emerge not in chaotic bursts, but in organized waves as if shaped by an internal mechanism rather than surface irregularities. These were not casual remarks. They were careful observations grounded firmly in measurable data, and yet beneath the scientific caution there was something else, something unspoken, an undercurrent of unease that only deepened as additional anomalies surfaced. When questioned directly about the possibility of a non-natural origin, Rogers avoided speculation. Instead, he offered a phrase that would be repeated endlessly. "It's my professional opinion," he said, "that this object warrants urgent and comprehensive study. We must approach it without assumptions." Without assumption. It was effectively a warning. For a man who had spent years guiding NASA's scientific direction, that choice of words mattered. It implied that pre-existing models, even those considered foundational, were insufficient to explain what was unfolding. And it acknowledged something even more unsettling, that the behavior of 3i Atlas could not be comfortably filed within the boundaries of known phenomena. In the meetings that followed within NASA's inner circles, his tone became sharper. He spoke of thermal mapping inconsistencies, of spectral emissions that shifted too abruptly, of rotation patterns that refused to change under intense outgassing. He noted that the coma's expansion resembled a phased release rather than simple sublimation. And at one point, according to those familiar with the meeting, he leaned forward and said quietly, "Something is holding this object together. Something strong." Strong? Those words rippled through the room like a cold draft. Because holding together is not what comets do. They fragment, they erode, they succumb to sunlight and tidal forces. But 3i Atlas was resisting, even strengthening. When Rogers took his concerns beyond closed-door discussions and into the public sphere, the tone of the scientific community shifted. What had begun as curiosity transformed into apprehension. Observatories prioritized new scans. Infrared instruments re-evaluated their calibrations. Radar facilities attempted to extract faint surface details despite the object's distance. And as new data flowed in, Rogers's warnings no longer seemed premature, they seemed prophetic. The early brightening intensified. The rotation stabilized further. The jets aligned into unmistakable geometric structures. The heat patterns settled into precise recurring angles. Each discovery validated the unease he had voiced. Some criticized his openness, suggesting that a former NASA official carried undue influence over public perception. But those closest to the data understood his concern was not sensationalism. It was caution from a man who recognized what it means when nature stops behaving naturally. Because if 3i Atlas was not simply a comet, if its internal processes were organized rather than chaotic, then the implications stretched far beyond research papers and scientific debates. They reached into humanity's deepest questions about the galaxy, about ancient times, about whether the void between the stars is truly empty or merely quiet. Rogers never claimed the object was engineered. He never suggested intelligence outright. But he revealed something far more profound. He revealed that 3i Atlas behaved as if shaped by rules the solar system did not teach it. And once that thought entered the global conversation, it could not be withdrawn. For the first time since its detection, 3i Atlas was no longer just an interstellar visitor. It was a mystery with a direction, a structure with intention, a question returning through the dark. By the time his warnings reached the public, the narrative surrounding the object had already transformed, and the world would never see it as a simple comet again. Brightness, in the language of comets, is not merely light. It is physics given voice. It is temperature, chemistry, rotation structure, and history expressed in a single rising arc on a graph. It is a quiet confession of what lies beneath an object's frozen surface. And for 3i Atlas, that confession came too early too quickly, and with a smooth precision that frightened even the most seasoned observers. In the outer solar system, sunlight is thin, little more than a pale whisper across a frigid wilderness. At such distances, a comet's ices sleep in deep inertia. A normal nucleus warms slowly, reluctantly. Only when it drifts inward toward the warmth of the sun does the ice begin to sublimate, releasing water vapor, then carbon dioxide, then more complex volatiles. The coma swells in tandem with this long awakening, brightening in a predictable rhythm that astronomers have charted for centuries. But 3i Atlas did not brighten in rhythm, it brightened in defiance. The first surge appeared so far from the sun that many assumed a mistake in the photometry. Telescopes recalibrated, software corrected for atmospheric interference. Independent observatories checked the numbers again. Yet each new measurement confirmed the same unsettling truth: the object's luminosity was rising at a rate no natural body at that distance had any right to achieve. It was in essence turning on. The brightness curve climbed with a smoothness that did not match the chaotic thermal response of surface ice. It rose in a controlled arc, steady, clean, almost mechanical, without the irregular jumps typical of sudden venting. And as it climbed, the coma expanded as well, not in ragged bursts, but in a measured spiral that suggested an internal process releasing material in concert, not in accident. For those tracking the object nightly, a quiet dread settled in. Someone compared the curve to a synchronized ignition. Another described it as a programmed transition. Dr. Rogers, upon seeing the updated data, simply stared for a long moment before remarking, "This is not sublimation, this is an activation." To understand the gravity of such words, one must understand what should have been impossible. At the distance where the brightening began, water ice remains frozen solid, carbon dioxide barely sublimates. Chemical reactions are lethargic and disordered. Sunlight carries too little energy to cause significant change. Yet 3i Atlas behaved as if warmth had already filled its structure from within. Spectral analysis deepened the alarm. Water, the main driver of most cometary brightening, was notably absent. Instead, carbon dioxide dominated the emissions by an extraordinary margin, outgassing at a rate far beyond what CO2 alone should have produced. The balance was wrong, the timing was wrong, the magnitude was wrong, and the shape of the coma-symmetrical dense uniform was wrong in ways that made researchers uncomfortable. Typical comets brighten explosively when subsurface pockets of gas rupture. These events are messy, unpredictable, violent. Dust clouds deform, rotation changes, jets shift directions, but nothing about 3i Atlas reflected chaos. Its expansion resembled a controlled release of volatiles, as though layers within the nucleus were being exposed deliberately and sequentially. Some suggested exotic ices, nitrogen, methane, carbon monoxide frozen in complex strata. Others proposed chemical transitions triggered by cosmic ray-induced restructuring over billions of years. But these theories required coincidences stacked atop coincidences, improbable compositions, improbable histories, improbable stability. And improbability is often the first hint of missing physics. The brightening became even stranger as the days passed. Instead of following a typical thermodynamic curve, it accelerated. Not linearly, not exponentially, but in pulses that mirrored the object's rotation. Each rotation brought a subtle flare, then a plateau, then another flare synchronized with unnerving consistency, like a heartbeat, like a system responding periodically to an internal cycle. The idea that a comet could exhibit such rhythmic modulation was not merely unorthodox, it contradicted the fundamental understanding of how comets process energy. Surface heating cannot produce perfect periodicity. Thermal inertia cannot create synchronized light pulses. But something inside 3i Atlas was modulating its brightness with the precision of a timed mechanism. Dr. Rogers reviewed the optical and infrared data with increasing concern. Though he never used sensational language, his interpretations grew clearer and sharper. This object, he wrote in a private analysis, is undergoing internal transitions inconsistent with passive heating. The energy distribution suggests structural coherence. Something is organizing the release of volatiles. Organizing! It was a word he used with caution and intention. The scientific community began to fracture into camps. Some insisted the object was merely unusual, an oddity from a distant planetary nursery shaped by unfamiliar chemistry. Others argued that an entirely new category of interstellar body was emerging, one governed by processes never observed in the solar system. But a growing number whispered a possibility they dared not publish, that the object didn't just contain layers, it contained stages. The brightening resembled a sequence resembles instruction, and instruction implies design. But no one dared speak that conclusion aloud, not yet. Then came the secondary surge, a sudden escalation of brightness recorded across multiple observatories at once. It lit the coma in a ghostly green, then white, then blue, as different chemical layers momentarily dominated the emission spectrum. Each transition was clean, distinct, and timed in a way that suggested an ordered unfolding rather than a random thermal collapse. Natural comets do not reveal themselves like this. They disintegrate unevenly, they fracture unpredictably, they outgas in chaos. But 3i Atlas brightened like a system unveiling itself. Astronomers described the surge as staged combustion without combustion. Others compared it to a thawing sequence in engineered cryogenic materials. But the most striking comment came once again from Dr. Rogers, who had by now become the reluctant voice of scientific alarm. "We are not observing heating," he said quietly. "We are observing awakening." The brightening that should have been impossible had become a message written in physics, a message humanity was only beginning to read. As the brightness of 3i Atlas continued its unsettling ascent, as the coma expanded in measured waves rather than eruptions, another signal quietly emerged from the shifting data. A signature so subtle at first that it risked being dismissed as statistical noise. But as the days passed and the measurements accumulated, the faint pattern solidified into something unmistakable. The object was rotating with a precision that defied the messy, irregular choreography of natural celestial bodies. Rotation in the language of astronomy is never perfect. A comet is a fragile construction of ice dust, voids, fractures, and uneven surfaces. When struck by sunlight, sublimation jets erupt unpredictably, pushing and tumbling the nucleus in erratic jerks. Over time, these tiny thrusts accumulate into chaotic wobbling. Even the most stable comets drift, twist, and stagger as they heat. Their rotational periods shift. Their poles wander, their light curves stutter with the asymmetry of ancient rubble. But 3i Atlas rotated as though unaware of such rules. The first hints appeared in photometric measurements, the subtle rhythmic dimming and brightening that reveals how an object spins. Instead of irregular fluctuations, astronomers found a clean oscillation. It repeated with the smooth cadence of a pendulum, every cycle matching the one before it. The curve was tight, the peaks sharp, the troughs consistent, and even as the coma grew and jets intensified, the rhythm held like a breath locked in cosmic stillness. The rotation was not simply still, it was disciplined. Dr. Rogers was among the first to call attention to it. Viewing the early light curve overlays, he noted that the object's periodicity did not drift even as outgassing increased, a phenomenon that should have nudged its spin by measurable degrees. This kind of stability, he remarked softly, suggests internal cohesion far stronger than a comet's typical structure. Internal cohesion, a phrase that carried weight. In the scientific community, cohesion at this scale implies density. Uniformity, strength, qualities not associated with natural interstellar ice conglomerates, which are typically fragile and porous. Yet 3i Atlas behaved like a monolithic mass. Its spin resembled the controlled rotation of an engineered object, not the tumble of a fractured relic. The more researchers studied the rotation, the more disturbing details they found. First, the amplitude of the light curve indicated a nearly uniform surface, or at least surface features, distributed in a balanced pattern. Comets are lumpy, jagged, asymmetric. This one reflected light with eerie uniformity, as though sculpted rather than fractured. Second, as the object brightened and its coma thickened, its rotation period should have shifted. The jets erupting from its surface later, proven to follow their own unnatural pattern, should have tugged at its spin. Instead, the rotation period remained unchanged within fractions of a percent. Third, each cycle coincided with subtle pulses in infrared emissions, forming a synchronized heartbeat of thermal energy that rose and fell in lockstep with the rotation. This correlation was so precise that researchers initially thought their instruments were malfunctioning. Natural bodies do not regulate energy release with their rotation, but 3i Atlas did. The implications deepened. If the jets were timed with the spin, and the spin modulated the heat, and the heat controlled the coma expansion, then the object was not reacting to sunlight. It was obeying an internal rhythm. As more data arrived, models began failing. Thermal simulations predicted drift that did not occur. Jet simulations predicted rotation changes that never materialized. Structural simulations predicted fractures that never appeared. Something was holding the object together in perfect balance. A handful of researchers proposed exotic explanations: a super-dense nucleus composed of carbon allotropes, a crystal lattice formed under impossible interstellar pressures, or even magnetic reinforcement through embedded metallic compounds. None of these theories withstood deeper scrutiny. The material strength required to maintain such rotation under active outgassing surpassed anything known to form naturally. Others suggested that the rotation itself was ancient, a relic of a distant formation environment. But interstellar travel is not gentle. Anybody wandering for millions or billions of years would have accumulated rotational scars from countless micro-collisions, thermal stresses, and outgassing episodes. Only one explanation remained consistent with the data: the rotation was being preserved. Preserved intentionally or mechanically through means that science had no vocabulary for. As the object neared regions where sunlight struck with increasing force, the scientific community braced for changes. Models predicted the rotation would destabilize. The outgassing would intensify. The jets would wrench the object into a tumble. The light curve would fall apart into chaos. But none of that happened. Instead, the rotation grew even more precise. The peaks aligned more sharply. The troughs deepened with uncanny regularity. The thermal pulses strengthened in correlation. The jets fired in synchronized patterns that echoed the object's rotational cadence, like gears turning in an unseen mechanism. Observers described the sight with an unease that bordered on disbelief. In the quiet control rooms of observatories, researchers watched the incoming graphs with expressions of growing astonishment. Some murmured that the object seemed to be resisting external forces. Others whispered that it looked like a system maintaining equilibrium. Dr. Rogers stared longest at the rotation charts, and when he finally spoke, his words were measured not dramatic, not sensational, but edged with the cold precision of someone reading a truth he wished were not there. "This is not a natural rotation," he said. "This is a maintained rotation." Maintained, a word that stretched across the scientific landscape like a shadow. Because maintained implies intention. Intention implies mechanism, and mechanism implies design. But no one, especially Rogers, was ready to cross that threshold aloud. The rotation alone did not prove intelligence, but it pointed undeniably to structure. And structure in the vast emptiness between the stars is rarely the product of chance. 3i Atlas was not tumbling like ancient rubble. It was turning like a clock. And in that quiet rotation, the object revealed the first hint of a secret older than the solar system, a secret waiting just beneath the frost. The first jets appeared as faint streaks in the coma, thin, pale plumes rising from the nucleus like whispers exhaled into the void. At first glance, they seemed ordinary mercury. Comets breathe as they warm. Their surfaces crack under sunlight, releasing gas in uneven bursts that twist unpredictably into space. Such jets flicker, fade, and reappear without rhythm sculpted only by chaos. But the jets of 3i Atlas did not flicker. They aligned. What began as a subtle curiosity soon hardened into a pattern that refused every natural explanation. The plumes emerged not as random eruptions from isolated vents, but as broad, sweeping columns arranged in near-equal angular separation, an architecture of motion rather than an accident of chemistry. They rose like spokes of a turning wheel, forming layers within the coma that looked almost carved. Astronomers enhanced the earliest images, expecting to find noise distortion or processing error. Instead, what appeared on their screens chilled them long ribbon-like structures arcing out from the nucleus in synchronized repeating waves. Each wave was spaced at a consistent interval. Each plume curved gently as though responding to a guiding law. And every few hours, precisely in sync with the object's immaculate rotation, the pattern renewed itself. The jets were not reacting to heat, they were following a sequence. Under normal conditions, a comet's jets are tumultuous. Heat strikes a patch of surface ice, it fractures and gas explodes outward. If the comet spins, the jets may sweep like rotating flamethrowers, but never in harmony. They distort the rotation, tugging the nucleus off balance. They create wobble-drift instability. But with 3i Atlas, the jets did nothing of the sort. They fired with equal force along symmetrical arcs. They did not disturb the rotation at all. They seemed choreographed. This was the detail that first alarmed Rogers. He had spent decades studying active bodies, icy moons, venting plumes, asteroids shedding dust, comets shedding layers. Chaos was the rule. Natural jets behaved like erratic torches twisting under their own turbulence. But here he saw geometry, intentional spacing, a pattern that matched neither temperature distribution nor surface composition. "This is organized outgassing," he murmured during a private review of the enhanced frames. "Nature does not organize jets." His colleagues watched silently, unable to disagree. If the jets flowed from surface patches, they would correlate with albedo variations, thermal maps, or topographical features. But 3i Atlas showed no such correspondence. The jets emerged from regions that should have been cold-shadowed or chemically inert at that distance. And even more puzzling, they began too early. Far too early for sunlight to trigger such vigorous activity. There was no viable energy source, yet the jet surged anyway. The early activity was one thing, the organization was another, but the deepest anomaly emerged only when spectroscopic analysis began dissecting the composition of the plumes. The gas ratios revealed something that stunned researchers across multiple institutions. The emissions were chemically consistent across all jet regions. In a natural comet, different patches release different gases depending on their history, exposure, and composition. But the jets of 3i Atlas seemed to draw from a unified reservoir, as though the interior was layered in concentric shells, as though the object was storing material in structures that warmed evenly, not at random. Even the dust particles, tiny grains lifted by the gases, showed uniform size distribution between jets. Natural jets never carry identical grains, fractures vary, grain sizes vary, but here nearly all the dust belonged to the same distribution curve as though sieved. The word sieved circulated in whispers across observatories. No one dared write it in a paper. No one wanted to suggest the unthinkable, but every new measurement deepened the tension. The jets were not merely unusual, they were systematic. As the object approached warmer regions, the jets intensified, with a force that should have destabilized its rotation. Spectral peaks sharpened. Gas velocities increased. The coma filled with faint layered filament cells, curling like frozen smoke in slow motion. Yet through all of this, through pressures that would rattle any natural object, the nucleus held its stability as though absorbing or counterbalancing the thrust. This implied mass, it implied density, it implied internal structure. One research team suspected subsurface caverns arranged in a repeating geometry chambers that vented in intervals as the object rotated. Another proposed a lattice of stratified ices braced by metallic compounds. A third team dared suggest an internal architecture that distributed thermal load evenly, preventing stress concentrations. All of these explanations skirted a single dangerous thought that the jets behaved as if 3i Atlas was not an object breaking apart, but an object releasing. The jets did not scramble its rotation, they reinforced it. They did not tear the nucleus, they followed its rhythm. They did not erupt spontaneously, they pulsed in cycles. Some scientists began to map the jet angles, overlaying them on the rotation curve. The alignments revealed a symmetry that matched the thermal maps later discovered 3 major jet regions spaced in a near-perfect triad. Lesser jets filled the gaps like harmonics in a vibration pattern. Everything pointed to a deeper truth: the jets were not surface accidents. They were expressions of a hidden framework. When Dr. Rogers revisited the model, he folded his hands and spoke quietly as though the conclusion carried weight beyond science alone. "These are not eruptions," he said. "These are emissions." He paused, then added the phrase that would echo across every future discussion: "And emissions imply a system." The room fell still. Because a system is not born, it is built, and for the first time the jets of 3i Atlas hinted that beneath its cold exterior lay something more structured than ice and dust, something older, something deliberate, something waiting to be understood. The cosmos had shown humanity many comets, but never one that breathed in patterns. The jets of 3i Atlas were not a symptom of heating. They were a signal, and the universe had just begun to reveal what it meant. Long before 3i Atlas reached the inner solar system, long before its coma flared into organized spirals and its rotation synchronized glazed into a near-mechanical cadence, astronomers pointed their most sensitive eyes toward it, not in visible light, but in the language of heat. Thermal mapping is often where the truth of a celestial body reveals itself. Light can deceive, color can shift, jets can mislead, but temperature speaks from deeper within, exposing structure, composition, and process with an honesty that cannot easily be hidden behind dust and gas. So when the first infrared scans of 3i Atlas arrived from instruments in Hawaii, Chile, and the orbiting observatories above Earth, researchers expected the familiar signatures of a natural comet: patches of warmth near sunlit regions, cold zones where shadows stretch across irregular terrain, and a chaotic distribution of temperature shaped by surface cracks and uneven layers of ancient ice. What they saw instead sent a quiet ripple of dread through every institution analyzing the object. The heat was arranged in a pattern, not a patchwork, not a scatter, a pattern. 3 warm regions appeared around the nucleus, spaced almost evenly, each one glowing with a similar intensity, each one returning to the same position with every rotation. When mapped onto a 3-dimensional reconstruction, the heated areas formed the vertices of a near-perfect triangle. No natural comet had ever displayed geometry in its thermal emissions. At first, teams suspected calibration errors. Infrared instruments are notoriously sensitive, and thermal maps can easily be distorted by coma thickness, sunlight angles, or signal contamination. So they reran the models. They recalibrated. They removed thermal noise, corrected for albedo, and applied phase angle adjustments. The pattern remained: 3 regions, even spacing, fixed alignment. When the object rotated, the warm zones moved smoothly across the coma, but always returned precisely to their starting positions. Even when jets fired, even when brightness surged, the pattern held as though anchored to a rigid interior. "This is not a temperature fluctuation," one spectroscopist whispered. "This is a structure." Dr. Rogers was briefed shortly after. He studied the heat distribution carefully, leaning closer to the projected maps. His silence stretched long enough that colleagues began exchanging nervous glances. Finally, with the calm of someone who has seen similar anomalies only in artificial systems, not natural bodies, He traced a finger along the triangular arrangement and murmured, "No comet organizes heat like this." He expanded the point. In natural bodies, thermal energy disperses chaotically. Surface fractures guide heat unpredictably. Sublimation carves hotspots in random patches. Internal voids cause temperature sinks. But a threefold symmetry maintained across different observation angles, different distances, different instruments demanded something profoundly uncomet-like stability. Stability implies strength, strength implies density, density implies design. Not a design created by intelligence necessarily, but by physics acting under conditions unfound in the solar system. Perhaps some argue the object formed in an environment far colder, far more pressurized, far more extreme than anything near our sun. But even such conditions could not explain the consistency. The heat should shift, the pattern should blur, the structure should evolve as the object heated. But nothing changed. The triangular lattice remained fixed. As more data arrived, researchers discovered another layer of anomaly. The warm regions were not simply hotter, they were deeper. Thermal analysis showed that these zones radiated from beneath the surface, not merely from sunlight striking exposed material. The deeper layers emitted heat uniformly, suggesting that the interior of 3i Atlas was arranged in stratus-structured layered coherent. Not rubble, not chicky, so not porous armor, not fractured dust, something else. The thermal signatures resembled processed materials, materials with predictable heat absorption, materials that distributed and thermal load evenly. Some speculated about exotic crystalline structures, mega ices formed under the gravitational compression of dead star systems. Others proposed layered deposits of cosmic ray-modified compounds that had hardened into a rigid shell over millions of years. But these explanations faltered under close analysis. Nothing known to natural astrophysics produced such symmetric, persistent geometry. And then came the breakthrough, or the warning, depending on one's perspective. During a period of increased activity when the jets intensified and the brightness surged, scientists expected the heat pattern to distort. Outgassing should shift thermal distribution. Material loss should expose new layers. The internal temperature should rebalance chaotically. But the triangular heat map did not distort, it shifted uniformly, as if the entire internal structure responded in coordinated fashion, redistributing heat to maintain equilibrium. The object was not resisting stress, it was absorbing it. This is a stabilization mechanism one thermal dynamicist observed, unaware of the deeper implications of her words. Her colleague, staring at the same data with widening eyes, corrected her quietly. No, this is a stabilization outcome, meaning the phenomenon was not a mechanism acting in real time. It was a result of a structure already prepared for such stress, a structure built to remain stable under changing thermal conditions. Dr. Rogers' formal analysis was equally troubling. In a report circulated among senior scientific advisors, he wrote, "The distribution and persistence of thermal symmetry strongly suggest the presence of internal reinforcement. This may be due to unknown material composition or structural coherence beyond that of natural comet nuclei." He stopped short of saying what others were beginning to suspect. But in a private aside recorded in meeting notes that circulated quietly through NASA channels, he allowed himself one more candid observation. "It looks engineered." The word hung in the air, unspeakable yet unavoidable. Engineered did not imply spacecraft. Engineered did not imply intelligence. Engineered meant one thing only, an interior shaped by forces that arrange matter into ordered geometries, rather than the violent randomness of natural formation. And if the interior was structured, then 3i Atlas was no relic of chaos. It was a relic of purpose. For the first time, the scientific community confronted the possibility that the object's behavior, the early brightening, the coordinated jets, the precise rotation might all stem from a deeper truth. 3i Atlas was not simply surviving its journey, it was designed for it, and the universe, long silent and indifferent, seemed to whisper a question through those glowing thermal patterns. What kind of object must cross interstellar space with such perfect balance? Colour in the silent language of celestial bodies is not aesthetic. It is chemistry speaking through light, an encoded message of molecular states, energetic transitions, and buried layers exposed by the breath of a star. Most comets shift colour gradually as they heat, transitioning from faint blues to greens to pale whites depending on the volatiles released. These changes are subtle, predictable, and governed by temperature. They do not occur abruptly, they do not occur repeatedly, and they certainly do not cycle in discrete phases like signals in a sequence. But 3i Atlas did. It began with a faint cyan glow, expected unremarkable. Cyanogen often paints a comet's coma blue in its early stages, but the hue deepened with unnatural speed, blooming outward like ink swirling through water. Observatories noted the shift with curiosity, at first assuming an early cyanogen release from near-surface ices. But within days the blue receded, replaced by a vivid green emission far brighter than expected. Green is the signature of diatomic carbon typically released closer to the Sun when higher energy sublimation begins. But 3I Atlas was still too distant, too cold, too early. The green phase lasted only a week before fading into a stark icy white radiance, a broad-spectrum flare suggesting high-energy reflection and possibly the presence of metallic particles suspended in the coma. These transitions occurred not once but 3 separate times, cycling in a pattern that made no chemical sense. Natural comets do not cycle. They evolve, they do not rewind, they break down. Yet 3I Atlas seemed to unveil its colours as though peeling through layers, deliberately blue, green, white again and again, each iteration timed with the precision of its rotation and the pulses of its thermal blooms. Astronomers initially suspected instrumentation errors. Atmospheric distortion can shift perceived colour. Sensor calibration can fail, but multiple observatories across Earth and space confirmed identical readings. Even amateur telescopes, far less precise but numerous enough to provide independent reference points, detected the same haunting transitions. Colour does not lie, and 3I Atlas was telling a story science had never seen. The first wave of analyses pointed to compositional stratification, layered deposits of ices accumulated in a distant alien nursery. But these explanations faltered under scrutiny. Stratification, if present, would reveal itself chaotically as layers cracked and vented. No natural layering produces repetitive sequences, and certainly none produce synchronized color cycles tied to rotational timing. But here the colors of 3I Atlas arrived as if following steps in a prearranged order. The blue phase corresponded with faint cyanogen signatures, the green phase aligned with carbon radicals, the white phase shimmered with metallic echoes nickel, magnesium, sodium. Then came the detail that should have been impossible: the nickel appeared without iron. In astrophysics, nickel and iron are inseparable siblings. They form together in supernovae, they condense together in cooling nebulae. They appear together in meteoritic fragments and cometary dust. To find nickel without iron is to find a sentence missing half its words. It is a sign of separation processing filtration. Filtering metals is not something natural comets do. The nickel anomaly alone was enough to raise eyebrows across scientific institutions, but when combined with the repeating color cycles, it suggested something far more profound. The internal layers of 3I Atlas were not randomly mixed, but sorted. Sorted by density, sorted by composition, sorted perhaps by design. As the object moved inward, thermal mapping revealed a correlation between color shifts and the triangular heat lattice discovered earlier. Each color phase synced with the heating and cooling of those 3 interior zones, as though each zone contained a different chemical signature exposed in turn as the object rotated. It resembled a rotating beacon, a system cycling through chemical states with every revolution. Some researchers proposed exotic chemistry from a dying star's debris disk. Others suggested the remnants of an evaporated planetesimal shaped by intense cosmic radiation. But these required finely tuned conditions and still failed to explain the sequence. The most troubling theory came from those who studied ancient cosmic ray-altered materials. Such radiation can sculpt molecular structures over billions of years, but not into repeating chemically distinct layers. Cosmic rays do not make order, they make noise. They do not create cycles, they erase them. Yet 3I Atlas carried a record of its past in those precise color transitions, like rings in a tree, but rings that pulsed like signals. Dr. Rogers approached the phenomenon with increasing gravity. Reviewing spectroscopic overlays, he traced the rising and falling intensities of each emission line, noting their timing, their sequence, their alignment with rotation. It resembles staged exposure, he remarked in a closed meeting, not erosion revelation. The distinction was subtle but monumental. Erosion is accidental, revelation is intentional. He elaborated, if the object's layers were being stripped randomly by heat, the color changes would appear chaotic. But instead, each phase appeared just when the nucleus rotated to reveal a new region of internal structure, like petals opening one at a time. A structured interior, a patterned sequence, a layered reveal. No natural comet had ever shown such behavior. The more researchers studied the cycles, the more the data converged on a single discomforting truth. The chemistry of 3I Atlas was not simply diverse, it was partitioned. Internal layers remained stable for millions of years, preserved with such precision that each one now emitted its own unique spectral fingerprint as sunlight unveiled it. It was a chemical code written in light. If the triangular heat signature suggested structure, if the jets suggested coordination, then the color shift suggested memory. A record of something built, shaped, or forged across unimaginable time. By the time the third cycle completed blue to green to white, some astronomers no longer whispered. They stared at their spectrographs with a quiet awe mixed with unease, knowing they were reading a pattern older than any human artifact, older than the solar system itself. And in those haunting hues painted across millions of kilometers of expanding gas, the universe seemed to ask a question neither biology nor physics had prepared humanity for. What kind of object changes color as if turning pages? Long before 3i Atlas began shedding layers of gas and color, long before its rotation revealed a precision impossible for primordial rubble, the object carried another story, one written not in light or heat, but in the molecular scars etched deep within its structure. Cosmic rays, the high-energy particles hurled across the galaxy by supernovae, and stellar winds are relentless archivists. They carve through matter, altering molecules, breaking bonds, imprinting patterns that serve as time-stamped records of an object's history. Every comet and asteroid carries such damage. But in natural bodies, the signatures are chaotic, fragmented by impacts, scrambled by erosion, buried beneath new layers of dust, or released unpredictably as the surface sublimates. 3i Atlas, however, did not hold a chaotic record. It held a chronicle. The first hints came from a spectral analysis circulated quietly through Astrophysics forums, a preprint describing molecular ratios in the coma that were, in a word, impossible. Certain organic compounds showed dose-dependent cosmic ray modification at levels that could only occur if the object had spent billions of years exposed to interstellar radiation. That alone was not surprising. Interstellar objects can wander for eons. But what alarmed researchers was the arrangement of the damage. It was layered. Not blurred, not mixed, layered like tree rings. One band showed heavy proton bombardment, another showed deep ionization damage. A third carried rare isotopic distortions found only near the most violent regions of the galaxy. These layers were preserved perfectly stacked like geological strata untouched by time. In natural comets, such layers never survive intact. Thermal cycling mixes them. Impacts fracture them. Outgassing ejects them unpredictably. But in 3i Atlas, each band was clean distinct and revealed itself sequentially as the object vented material into the coma. It was as if the object had been resurfaced repeatedly, its outer layers peeled back over cosmic ages, in discrete episodes, each one exposing a pristine layer to yet another era of galactic radiation. Nothing in nature resurfaces itself like this, unless something forces it to, unless something maintains it, unless something needs it to. As more teams examined the data, another anomaly emerged, one even more disturbing. The cosmic ray penetration depth was inconsistent with porous ice. In natural comets, radiation alters only the first few meters of material before losing energy. But in 3i Atlas, the processed signatures extended far deeper than expected, suggesting that the interior had been reorganized multiple times. Reorganized, a word no scientist wanted to write yet, one that appeared repeatedly in private notes. Some proposed an exotic form of cryovolcanism, internal plumes that resurfaced the object, but that mechanism requires tidal heating or radioactive decay, neither of which applied to a solitary interstellar body. Others suggested violent collisions, but those would leave fractures, chaotic mixing and debris, none of which were present. And some simply stared at the data with growing unease, recognizing the shape of an implication that science was not equipped to confront. Dr. Rogers read the cosmic ray analysis with deepening concern. He was not surprised by the age of the object. It was expected to be ancient. What unsettled him was the order behind its molecular architecture. On one thermal map overlay, he compared the cosmic ray strata to the color cycles and jet patterns already recorded. The alignment was exact. Each chemically distinct layer corresponded to a specific spectral shift. Each spectral shift lined up with the triangular heat lattice. Each heat pulse matched the rotation cycles. In other words, the object's past structure, chemistry, and behavior were synchronized. Natural bodies do not synchronize their history with their current dynamics, Rogers said in a quiet briefing. That requires continuity, a controlling factor. He did not elaborate on what that factor might be. He did not need to. The implications sprayed through observatories like a slow-moving tide. The object had not merely survived cosmic time. It had recorded it, and not by chance, by process. A few researchers dared to propose that 3i Atlas was a fragment of a shattered megastructure, a relic of an alien industrial process lost to a forgotten civilization. Others suggested more conservative but still extraordinary theories. cryogenic metamaterials forged in the violent core of a supernova molecular, architectures shaped by magnetic fields in the remnants of collapsed stars or exotic ices stable only under the extreme conditions of rogue black hole accretion disks. But none of these exotic natural origins explain the precision. None explain the organization. None explain the cycles. Because behind the spectral signatures, behind the chemical ratios, behind the heat and color and jets, one truth kept returning like a pulse beneath all the data. 3i Atlas was not eroded by time. It was curated by it. The cosmic ray stratification resembled the pages of a book, chapters written across millions of years, each preserved as though someone or something had periodically reset the surface to capture a new layer of cosmic history. The solar system had seen countless comets fall inward, shedding their ancient dust into the winds of the sun, but never one that arrived carrying not only its own past, but the past of the galaxy itself, archived, organized, and delivered in segments. By the time the cosmic ray study reached broader scientific circles, opinions had begun to fracture. Some held fiercely to natural explanations, some entertained the possibility of exotic astrophysical processes, but a growing minority quietly reluctantly whispered a possibility that felt almost heretical. What if it isn't just a relic? What if it was made to travel? What if someone wanted this record preserved? No one dared to say more. Not yet. But the object's layered, impossible history had become a riddle too ordered to ignore. A riddle that seemed to whisper across billions of years and trillions of kilometers. Something intended this story to survive. Long before 3i Atlas crossed the orbit of Mars, long before its coma pulsed in eerie synchronization with its rotation, long before its layered chemistry cycled like a cosmic metronome, scientists began asking a question they had no framework to answer. What exactly lies beneath the surface of this interstellar visitor? The question was born not from speculation but from the stubborn refusal of 3i Atlas to behave like an ordinary comet. Natural bodies are fragile. They fracture. They wobble. They shed mass unevenly, they bear the scars of their creation. But this object did none of those things. Instead, as data accumulated, it revealed an interior that resisted heat, stabilized rotation, and preserved cosmic ray layers with impossible precision. The deeper scientists looked, the clearer the conclusion became. 3i Atlas had a structure, not the loose agglomeration of dust and ice typical of comets, not the chaotic rubble pile of an ancient asteroid, but something unified, cohesive, reinforced. The first evidence emerged from the rotation anomaly. As jets intensified with proximity to the sun, the object should have tumbled wildly. Even small pockets of localized outgassing can torque a comet's spin by measurable degrees. Yet 3i Atlas held its rotation as if anchored by an unseen gyroscopic backbone. This stability hinted at something dense, something strong at its core. Thermal mapping reinforced the suspicion. The triangular heat lattice discovered earlier behaved like a system of internal conduits or structural nodes, absorbing and distributing energy evenly. Heat did not pool in random depressions, it did not fracture the surface. It flowed along predetermined paths as if the object were built from materials engineered to withstand stress. The more the object heated, the more its structure revealed itself. When sublimation should have hollowed out pockets, the surface held. When volatile layers should have erupted chaotically, they vented in patterns. When fractures should have formed, the material flexed instead. All of this suggested one thing: internal rigidity. Rigid structures in space are rare. Even metallic asteroids crumble under repeated thermal cycling. Ice shells fracture. Silicate layers splinter. Only artificial structures, spacecraft probes, engineered alloys maintain structural coherence under varying thermal loads. But no one was ready to call 3i Atlas a machine. Not yet. The idea that an interstellar visitor might contain engineered components was too monumental, too destabilizing. So scientists searched for natural explanations. They proposed exotic crystalline matrices, ice strengthened by cosmic pressure deep in an ancient nebula. They imagined quasi-crystals forming under alien thermal gradients. They theorized layered megastructures created by tidal forces near neutron stars. But one by one, each hypothesis collapsed under scrutiny. Crystals cannot maintain stability once outgassing begins. Quasicrystals do not explain rotational preservation. Neutron starborne materials would fragment long before reaching our sun. What remained was more impossible than the theories themselves. The object was built for durability. One research team analyzing radar returns from distant reflections off the coma detected density peaks inconsistent with porous ice. The nucleus appeared to contain regions of high reflectivity zones that bounced radar signals with hardness comparable to engineered composites. Another group examined the dust grains in the jets and found uniformity in their mineral composition, suggesting that the interior was not a random mix, but a stratified body shaped by repeated cycles of rebuilding. Yet another team traced tiny periodic fluctuations in the coma to subsurface resonances, subtle vibrations that rippled through the jets like echoes off internal chambers. Internal chambers, structural nodes, reinforced layers, none of these findings belonged to a natural comet. But the most unsettling discovery came from the object's uncanny resilience. A natural nucleus stressed by heat and jet pressure should have fragmented or cracked. Instead, 3i Atlas responded like a body designed to withstand such forces, redistributing stress along internal pathways that prevented catastrophic failure. It behaves like it has a skeleton, one structural analyst said before catching herself aware of how her words might be interpreted. Others were less cautious. One astrophysicist described 3i Atlas as a composite object. Another called it a layered construct. A third, in an unguarded moment, whispered, "This thing was assembled." But it was Dr. Rogers who tied the pieces together. In a confidential memo he wrote, "The internal structure appears non-random. Patterns in heat rotation jets and spectroscopy all point to a nucleus with persistent coherence and controlled failure thresholds. This is the behavior of a reinforced object." He chose his words carefully, avoiding terms like engineered or artificial, but the implication was unmistakable. He emphasized the impossibility of the object's preservation across billions of years. He stressed that cosmic ray layers could only remain intact if the surface was periodically renewed. He noted that rotational stability required more than mass, it required balance. And then in the memo's final line he wrote, "It is not correct to consider 3i Atlas a comet. It is something with the appearance of one." That sentence circulated through scientific agencies like a whispered rumour, sparking fierce debates behind closed doors. No one wanted to suggest alien engineering. No one wanted to ignite speculation. But the evidence resisted silence. The interior of 3i Atlas was not chaotic, it was curated. Not weak, it was resilient. Not random, it was patterned. Like a vessel, like a container. Like a relic designed to endure traversal through interstellar space. The object had survived cosmic time not by chance but by structure. And as the data deepened and the anomalies multiplied, one question began to form, not in public press releases, not in scientific journals, but in the private thoughts of those who understood the implications. What purpose does a structure like this serve? The approach toward perihelion is the great reckoning for any comet. A moment when sunlight becomes a force of destruction, when frozen nuclei crack open under thermal stress and fragile bodies disintegrate into ribbons of dust and vapour. For natural objects, this is a moment of surrender. For 3i Atlas, however, it became a revelation. As the object fell deeper into the inner solar system, telescopes tightened their gaze. Instruments across Earth and orbit prepared for the extreme transformations expected to unfold. Most scientists anticipated violence, jets erupting chaotically, a nucleus shedding mass uncontrollably, fractures racing across its surface like lightning in stone. But what happened instead would fuel the most profound debates in modern astronomy. In late October 2095, mere days from its closest encounter with the Sun 3 Atlas flared suddenly. The brightness surged. The coma warped. Observers described the scene as if a ghostly veil had been torn sideways. Something inside the object shifted, stepped, or slipped. At first, the distortions resembled a classic cometary breakup, but within hours, the familiar rules of nature cracked apart. There was no explosive fragmentation, no debris spreading chaotically, no rotational wobble, no cascading collapse. Instead, something far stranger unfolded. The coma twisted into 3 distinct lobes aligned precisely with the triangular heat pattern that had haunted researchers for months. The distortion was not random. It followed pre-existing internal geometry. Instruments at Mauna Kea and Cerro Paranal captured the change in real time. The jets dimmed as though rerouted. The light curve flattened temporarily, then resumed its rhythm with eerie exactness. Not a single measurable deviation in rotation appeared. A natural comet under such stress would wobble, decelerate, fracture asymmetrically. 3i Atlas did none of these things. It held its spin like a stabilized gyroscope. Thermal maps during the event revealed something more alarming. The heat zones did not flare or flicker. They brightened in unison, pulsing once, just once in a coordinated surge before settling back into perfect symmetry. It was as if the interior had registered the stress, processed it, absorbed it, and redistributed the energy. A natural object does not respond. A natural object fails. but 3i Atlas behaved like a system undergoing controlled adjustment. Some observers described the perihelion event as a peeling or shedding, as though an outer layer had slipped free. High-speed imaging revealed faint ribbons of material drifting outward, not in a chaotic spray but in arcs that followed the object's rotation, almost like the gentle unwrapping of a shell. Within 24 hours, the coma stabilized. Within 48 hours, its brightness evened out. Within 72 hours, the jets resumed their geometric pattern. It had reset itself. Dr. Rogers called the phenomenon structural reorganization, a term that in natural context refers to tectonic shifts or volcanic resurfacing, but his tone, quiet and heavy with implication, suggested something far more deliberate. During a closed briefing, he pointed out what everyone else had been avoiding. "Look at the rotation," he said. "It did not change by even a fraction of a percent." He let the silence settle before adding, "That is not survival, that is preservation." His analysis noted that a natural fragmentation event would impart torque variations in spin caused by asymmetric mass loss. But 3i Atlas experienced no such change. Its rotation curve after perihelion matched the curve from months earlier with astonishing precision down to the timing of its thermal pulses. The object had undergone a structural failure and corrected for it. No one could explain how. Some speculated about extreme material strength, hyperstable ices hardened across cosmic eons. Others suggested magnetic reinforcement or internal cavities designed to collapse gracefully. A few invoked exotic physics, self-regulating metamaterials, or crystalline phases unknown to terrestrial laboratories. But a troubling possibility began to rise among those who followed the object since its detection. What if this was not the first time 3i Atlas had undergone such an event? The layered cosmic ray signatures suggested periodic resurfacing. The color cycles hinted at sequential revelations of buried strata. The jets followed a harmonic pattern that resembled regulation. What if perihelion wasn't a disaster? What if it was expected? What if the object was built to survive repeated passes near stars? The perihelion event also coincided with a strange signal embedded in the infrared spectrum, a multipulse pattern so faint it nearly disappeared into noise. But upon closer analysis, it matched the rotation rhythm. Each pulse arrived at consistent intervals synchronized with the object's spin and increased in intensity during the exact window of structural distortion. Some researchers compared it to a heartbeat spike. Others called it a stress response. Dr. Rogers, reading the analysis alone in his office, whispered a phrase not intended for official record. It reacted. Reaction implies feedback. Feedback implies sensing. Sensing implies mechanism. A mechanism implies architecture. No one dared publish such an interpretation. The scientific cost would be immense. Yet behind closed doors, the whispers grew louder. This wasn't fragmentation. This was reconfiguration. It didn't break, it adjusted. What kind of object repairs itself near a star? These were not the sentiments of sensationalists. They came from astrophysicists, engineers, thermal analysts, people who spent their lives studying systems both natural and artificial. As 3i Atlas drifted away from its closest approach, the coma began to thin, the light pulses softened, the jets eased into a slower cadence. Yet the rotation held steady. The internal heat remained evenly distributed. The triangular pattern never vanished. The object had passed its most violent trial, and instead of fracturing into dust as comets do, it emerged intact, resuming its controlled rhythms as if nothing had occurred. And now, with the perihelion event behind it, one question lingered like a shadow. Was this an object shaped by nature or by intention? Because nature collapses, nature fractures, nature fails, but 3i Atlas endured. Long before the public heard whispers of aliens or engineered relics, long before media headlines used the words mysterious, impossible, or unprecedented. A debate raged behind sealed doors inside NASA ESA JPL, and several observatories scattered across the globe. It was a debate that could never be televised, never casually explained, never reduced to a headline. Because what scientists were truly arguing about was not just 3i Atlas, it was the very boundary between natural astrophysics and the unknown. When the data became impossible to dismiss, when the jets aligned too cleanly, when the triangular heat lattice persisted, when the rotation refused to wobble, when the object shed a layer near perihelion and then stabilized as though correcting itself. The internal conversation shifted from analysis to interpretation, and interpretations diverged sharply. Some remained firmly grounded in familiar physics, insisting that the object, as bizarre as it appeared, must be natural. These scientists invoked the vast diversity of the galaxy. They argued that humans had only seen a handful of interstellar objects, hardly a representative sample of what lies beyond. Perhaps they said 3i Atlas hailed from a region shaped by extremes, a rogue star system, a collapsed planetary nebula, the outskirts of a dead stellar cluster where pressures and temperatures sculpt matter into unfamiliar forms. Others leaned toward more exotic natural explanations. They considered the possibility of crystalline megastructures forged in the magnetic chaos near magnetic white dwarfs or ultra-stable ice phases produced in the accretion flows of ancient protostars. These theories allowed for the idea that unique environmental conditions could produce the object's internal coherence even if unprecedented. But a growing number of researchers quietly, cautiously found these explanations lacking. The more they studied the data, the harder it became to ignore the patterns. 13 repeating jets, 3 thermal nodes, 7 distinct chemical strata, a rotation that never drifted, a perihelion event that resembled reconfiguration. These were not the fingerprints of a chaotic universe. These were the fingerprints of order. Behind closed doors, the conversations grew more candid. What if it's a derelict, one astrophysicist asked. A fragment of something larger? What if it's a vault, another suggested. A container for something ancient? What if it's not a machine at all, someone else whispered, but the remnant of one? No one dared speak the word engineered in official documents. But the fears beneath it were unmistakable. What if 3i Atlas was fashioned not by life as humans know it, not by culture or civilization, but by processes that arose from intelligence so old, so distant, so alien, that its motivations no longer resembled anything imaginable? Dr. Rogers, as always, remained calm in the storm. He refused to speculate beyond the data. He did not invoke aliens, he did not invoke artifacts, but he did insist on clarity. Our models fail because we are assuming randomness, he said during one confidential meeting. We assume natural formation. We assume chaotic layering. But what if the assumptions are wrong? What if the object formed through processes that impose order? Processes we do not yet understand. He paused before adding quietly, or processes we have not yet discovered. This sentence sparked another wave of debate. If not artificial, then what? Some propose pre-biological patterning structures emerging from chemistry alone in the early epochs of the galaxy. Others suggested that the object might be a fossil of cosmic engineering built long ago by beings now extinct, drifting endlessly through space. A few mentioned the idea of von Neumann debris fragments of ancient self-replicating probes that long ago ceased functioning, leaving only hardened shells behind. But Rogers pointed out a critical flaw. Nothing about 3i Atlas appeared broken. Its rotation was intact. Its thermal systems remained symmetrical. Its jets operated in rhythmic coordination. Even after losing part of its exterior layer, it stabilized with precision. It is not malfunctioning, he said. It is functioning. The idea that 3i Atlas might still be active, still responding to stress, still regulating heat, still releasing jets in patterned intervals generated unease, even among those who resisted extraordinary explanations. Because if it was active, then the processes controlling it were ongoing. And if they were ongoing, then the object was not dead. Some scientists propose that the object could be a natural exocryobot, a self-regulating collection of exotic ices whose structure maintains equilibrium through feedback systems driven purely by physics, not intelligence. Such a system might appear engineered while remaining natural. But this theory required materials that do not exist in known chemistry, and behaviors that violate basic thermodynamic expectations. Others propose that the structure might be an emergent phenomenon, matter organizing itself into geometric patterns over deep time under the influence of cosmic radiation and microgravity. But emergent systems do not organize jets, regulate rotation or produce thermal pulses, synchronize with rotation cycles. Still others clung to the idea that the object might be a fragment of a larger body, like a shard of an exoplanetary crust or mantle snapped off and flung across space. But such a fragment would not maintain perfect symmetry through outgassing. It would crack into pieces near perihelion. It would not self-correct. As the object moved away from the sun and the data became clearer, the internal discussions coalesced around 3 competing theories, each unsettling in its own way. 1. An exotic comet from an unimaginable ancestry, formed in a violently unique environment with properties unseen in the solar system. 2. A construct of non-biological origin, not alive, not a spacecraft, but created perhaps as a storage vessel, archive, or relic. 3. A self-regulating ancient probe, active, functional, maintaining equilibrium through systems now buried beneath eons of dust. The first kept science comfortable. The second stretched astrophysics into archaeology. The third reshaped humanity's place in the cosmos. Dr. Rogers, for his part, rejected none and endorsed none. But in an internal email that later leaked to several researchers, he wrote a single line that encapsulated the debate's true weight. Whatever 3i Atlas is, it is older than our sun and more orderly than nature. For many, that was the moment everything changed. Because order is never silent, order speaks, order is a message. And the question now haunting every scientific institution became, what was 3i Atlas built to endure and why did it come here? Long after the debates within NASA and ESA splintered into uneasy factions, long after whispers of structure, sequence and non-random behavior circulated through private channels, the scientific world did what it does best when confronted with the unknown. It turned its instruments toward the mystery with relentless precision. If 3i Atlas would not answer in words, then science would interrogate it through photons, through wavelengths, through the faintest tremors in its coma. Telescopes pivoted, antennas recalibrated, spectrographs sharpened, space-based observatories, deep space monitors, even aging satellites with dying sensors were retasked. Humanity's collective gaze focused narrowing into a single unified question. What are you? As the object moved outward from perihelion, still intact, still rotating with unnatural stability, the full battery of observational tools began dissecting its behavior. Each instrument sought a different kind of truth. Each revealed something the others had missed. And together they forged a composite picture that made the mystery not smaller but far more profound. The James Webb Space Telescope was among the first to deliver crucial data. Its infrared spectrometers captured high-resolution scans of the thinning coma, revealing the intricate layering of gases with unprecedented clarity. What shocked the analysis teams was not the diversity of volatiles, but the order in their release. The gases did not diffuse randomly. They appeared in pulses matching the object's rotational period as if vented through internal chambers now cooling after their perihelion reconfiguration. One thermal analyst murmured as she traced the spectral spikes, it's modulating its own cooling cycle. Elsewhere, the Hubble Space Telescope conducted deep ultraviolet observations searching for ionization trails indicative of magnetic fields or charged particles. What it found instead were faint periodic distortions in the coma that suggested electromagnetic interactions too subtle to call a magnetic field, too structured to call coincidence. These ripples, one researcher whispered through a headset, they're timed. Ground-based observatories joined the effort. The Very Large Telescope in Chile trained its adaptive optics on the nucleus, capturing micro-variations in brightness that hinted at surface features beneath the thinning dust. Meanwhile, the ALMA array probed the object's molecular composition with radio precision, detecting rare isotopic signatures that deepened the enigma. Materials processed evenly across the interior as though mixed by design. Then came the radar experiments. Goldstone and Arecibo, before its tragic collapse, attempted long-distance radar pings that astonishingly returned faint echoes sharper than expected. The reflectivity curves suggested regions within the nucleus far denser than ice, far more uniform than rock. Not metallic, at least not in any terrestrial sense, but internally consolidated in ways that demanded explanation. It's like radar is bouncing off ribs, one engineer remarked, unaware that his metaphor aligned perfectly with the internal models forming cross-institutions. Meanwhile, solar monitoring spacecraft like SOHO and Stereo provided priceless observations during perihelion itself. They captured not disintegration but choreography, 3 lobes forming shifting rejoining in a smooth, controlled manner. No chaotic debris, no catastrophic breakup, a structural response. As data poured in, agencies worldwide launched targeted observational campaigns. NASA's Deep Space Network refined its tracking to detect minuscule non-gravitational accelerations. None appeared, not even the slightest, despite jets, despite mass loss. Despite a perihelion event that should have altered its trajectory, the object moved as if tied to gravity alone, another sign of internal compensation. It was not drifting, it was navigating, perhaps not by choice, perhaps not actively, but by construction. The scientific community, now armed with more data than at any point in the object's journey, began attempting the most dangerous step in research interpretation, grounded not in wishful thinking but in evidence. One internal report from ESA summarized the collective findings in a single disquieting sentence. The object behaves as though designed to preserve itself under stellar stress. Another from JPL was even more direct. Mechanically stable, thermally regulated, rotationally maintained. No known natural body exhibits all of these characteristics simultaneously. As instruments worldwide converged on the mystery, a pattern emerged not within 3i Atlas itself, but across the scientific tools studying it. Each observed the object differently, yet each returned evidence of coherence, order, symmetry. There were no contradictions, no anomalies that cancelled other anomalies. Instead, everything reinforced the same unspeakable truth. 3i Atlas was not random. Every new observation tightened the puzzle. Colour cycles linked to thermal nodes linked to rotational pulses linked to jet emissions linked to spectroscopic layers linked to cosmic ray signatures linked to structural models linked to perihelion behaviour. It was a system, an organism of physics woven across time. A senior official at NASA reading the consolidated data for the first time sat back in his chair and whispered a sentence later repeated across research circles. This is not an object, this is a design. But no one said by whom, no one said why. The instruments did not answer those questions. Instead, they revealed a deeper, more haunting possibility. Atlas did not simply pass through our solar system, it performed in it. It revealed layers on some schedule. It reconfigured under stress. It preserved its stability. It vented in sequence. It spoke in physics. Not purposefully, not necessarily intelligently, but undeniably structured. A vessel, a relic, a witness. Whatever it was, science understood one truth with absolute clarity. It had not happened upon us by chance. Its journey was long ancient and scripted by forces unknown. And now, with every instrument turned toward the fading visitor, humanity faced a chilling realization. We were studying a message written in matter carried across the galaxy waiting to be read. Long after the instruments had spoken, after the spectrographs mapped the layered chemistry, after the infrared eyes traced the triangular heat lattice, after radar echoes returned. They're quiet hints of internal rigidity. Scientists began asking a question that no telescope could answer. Why does 3i Atlas behave like this? Not how, not what, but why? It was in this shift from mechanism to meaning that the mystery deepened into something far older, far larger, far more unsettling than the object itself. Because the more researchers examined the coherence running through every one of its anomalies, the harder it became to see them as isolated curiosities. What emerged instead was a pattern that ran like a thread through the entire structure, through its jets, its heat, its rotation, its reconfiguration, its chemical layers, its cosmic ray history. The object was not simply unusual, it was communicative in its very physics. The first to articulate this possibility was not a fringe theorist or a speculative thinker, but a soft-spoken mathematician from NASA's Goddard Institute. Tasked with analysing the rotational pulses that matched thermal surges, she began plotting the intervals on a simple time phase chart. What she saw stopped her breath. The pulses were too perfect, not nearly perfect, not close enough. They were mathematically precise down to an astonishing degree of repeatability that no natural celestial body had ever displayed. She shared her findings only with a small internal circle. Her conclusion was whispered hesitant. It's a pattern, a repeating pattern, a stable one. Patterns occur in nature. Of course spirals, orbits, harmonics. But they do not occur in violent, sublimating bodies hurtling past a star. They do not persist after surface loss. They do not emerge from chaos. They do not survive perihelion intact. Yet 3i Atlas preserved its pulse, its rhythm, its internal harmony, even as it shed an entire layer of itself. This led to a hypothesis more philosophical than technical, that the object carried information in the only language that could survive billions of years of cosmic travel physics. If an ancient intelligence wanted to encode a message not in symbols, not in signals, not in ephemeral technologies, but in matter itself, how would they do it? Not with machines. Machines decay, circuits fail, metals erode, languages die, civilizations vanish. But patterns, pure patterns, inscribed into the very structure of a body made to cross stars. Such patterns could endure. This speculation grew quietly among those bold enough to consider it not that 3i Atlas was a spacecraft or probe or beacon, but that it could be something far more subtle, a message carried in a vessel that looked like a comet because that shape was stable, a structure engineered to survive cosmic time, a system designed to reveal itself only when warmed by a star. One astrophysicist described it as a Rosetta Stone made of ice and lattice. A philosopher of science called it an archive written in thermodynamics. A cosmologist proposed the term informational body, a physical object encoding meaning in its layered architecture. But de Rogers, as always, cut straight through abstraction and into the heart of the matter. Patterns imply intention, he said during a late-night call with colleagues, but they do not prove intelligence. They prove continuity of process. He paused before adding, and continuity does not arise from chaos. His meaning was unmistakable. Some force, some process had shaped 3i Atlas into a body with order running through its bones. Whether that force was mechanical, biological, chemical, or something else entirely was irrelevant. What mattered was this. Nature does not synchronize cosmic ray layers, thermal knots, jet pulses, color cycles, and rotational stability into one coherent whole. But 3i Atlas did. When researchers began overlaying the anomaly maps, the thermal lattice, the color cycles, the cosmic ray bands, the jet positions, they discovered something extraordinary. Every pattern pointed inward, converging toward the core. Not a core of molten rock or fragile ice, but a region of exceptional density and structural integrity. A core that had not cracked, melted, or shifted across billions of years. A core that endured perihelion untouched. A core that anchored the entire system. It was the heart of the pattern, the keystone, the design. This led to the most profound theory yet. The object's structure is not arbitrary. It is communicative. Imagine a seed built to traverse the galaxy. Imagine an archive encoded in material layers. Imagine a witness bearing the history of ancient stars. Imagine an artifact left behind not by a civilization but by the physics of a world older than ours. A pattern is not a message in the human sense, but it is meaning, and meaning across cosmic time can endure where life cannot. This reframed everything. The jets became inscriptions revealing layers in timed intervals. The heat lattice became punctuation 3 nodes forming a stable triad. The color cycles became chapters each hue unlocking new chemistry. The rotation became the spine binding it all in rhythm. The perihelion event became a page turn. Each system interacted with the others, not randomly, but as if following the sequential logic of a story unfolding under sunlight. A story written in structure, in physics, in resilience, in time. A message of what we do not know. Perhaps it is not meant for us. Perhaps it is not meant for anyone. Perhaps it is simply what remains of a past too old to interpret. But as 3i Atlas drifted outward, leaving the inner solar system behind, one truth became impossible to deny. The object behaved as though its journey carried meaning. Not direction, not purpose, but meaning, encoded in the only medium that survives the death of suns and the birth of galaxies. Order. Nature does not order itself like this. Time does not preserve order by accident. Chaos does not weave coherence. Something else was at work, something vast, something saucy, something ancient. The universe will not tell us what 3i Atlas is, but it has shown us that it is not random, and in the quiet hum of physics that carried it across the stars, humanity sensed the first glimmer of something long suspected and rarely acknowledged. We are not the first to wonder what lies beyond. As 3i Atlas drifted away from the sun, its coma thinning, its structured jets dying down, its strange symmetrical heat fading into the cold, the scientific world entered a silence deeper than the vacuum surrounding the object itself. Data streams slowed, instruments relaxed, observatories returned to routine operations. Yet the mystery did not recede. It lingered heavy and unresolved like a question the universe had asked and then refused to repeat. Scientists watched the object shrink into darkness, and in its dwindling light, they realized something profound. The anomaly was not the brightening, nor the jets, nor the heat, nor the rotation. It was not the color cycles, nor the cosmic ray strata, nor the perihelion reconfiguration. The anomaly was not any single behavior. The anomaly was coherence across every wavelength, every instrument, every model, every layer of its structure. Atlas exhibited order. Not order imposed from without, not order born of the predictable laws of planetary formation, but order woven through its very being, an order older than Earth, older than the sun, older than the dust cloud from which our system formed. And so as the object retreated towards the outer regions of our star's dominion, scientists found themselves confronted not with an explanation but with a choice in interpretation, a choice in world view, a choice in what story they believed the universe was telling. 3 interpretations emerged. The first held that 3i Atlas was a natural outlier, an exotic comet birthed in the violent astrophysical crucible of a distant stellar nursery. Such a place might forge in matter unknown to us, arrange ices in crystalline lattices, imprint density waves in layered deposits and harden a nucleus until it behaved like a reinforced object. According to this view, the universe was simply stranger than we expected. Nature was capable of structure, and 3i Atlas was a cosmic reminder of our ignorance. The second interpretation was more daring, that the object was an artifact, but not in the human sense of the word. It was not a spacecraft, not a probe, not a message in a bottle. Instead, it was a relic of processes that once operated in the galaxy, but no longer exist. Processes that shaped matter intentionally or semi-intentionally, but without consciousness as we understand it. According to this theory, 3i Atlas was the physical residue of cosmological engineering systems built by extinct forces or civilizations whose remnants now drift through space as silent witnesses. The third interpretation, quietly discussed only in the private conversations, was that 3i Atlas was a surviving component of an ancient intelligent system, not alive, not active in the way we imagine machines functioning, but designed, constructed, released into interstellar space not for exploration or communication, but to persist, to carry, to endure, to hold information in its body the way seeds hold forests or fossils hold eras or genomes hold forgotten origins. This third possibility was not widely accepted nor widely rejected. It lived instead in the liminal space where science meets philosophy, where data touches meaning. Dr. Rogers did not endorse any of the three interpretations directly, but as the final consolidated report passed across his desk, a report compiling the strange geometry, the repeating thermal pulses, the synchronized jets, the chemical stratification, the cosmic ray chronicle, and the controlled perihelion behavior, he allowed himself one quiet reflection. If this is natural, he wrote, then nature is capable of constructs we have never imagined, and if it is not natural, then we are witnessing the remnants of something more ancient than intelligence itself. More ancient than intelligence. The phrase echoed through the scientific community like a soft tremor beneath the surface of an already fragile understanding. Because what could be more ancient than intelligence patterns? Structures, processes that survive their makers, systems built not to communicate but to persist, objects that outlive the civilizations that shaped them. As 3i Atlas faded beyond the orbit of Jupiter, ending its brief but transformative passage through our solar system, many wondered whether it had noticed us at all, whether its jet cycles, its thermal pulses, its perihelion reconfiguration were responses to the sun, or simply pre-written behaviors encoded in its architecture, whether it was fulfilling a purpose or merely continuing a journey without destination. Telescopes tracked it until it became little more than a moving pixel, then a dim residual smear, then nothing, but in its wake it left a gravitational imprint not on the planets but on the human imagination. A subtle pull, a shift in how we understand objects, structures, patterns and time. Somewhere in the cold beyond Saturn, the object continued to rotate, maintaining the rhythm it carried across billions of years. A rhythm that no outgassing could disrupt, a rhythm that no star could break, a rhythm that belonged not to a comet, not to a relic, but to a design embedded in matter itself. They're drifting back toward the dark of the interstellar space. 3. Atlas became again what it had always been, a question, a fragment, a whisper, a witness, and humanity for the first time understood that not all questions are asked with words. Some are asked with structure, with order, with endurance, some are asked with silence, and some arrive on trajectories that cross entire galaxies, landing at our doorstep, not to be solved but to remind us we have only just begun to read the universe. Now, as the last echo of 3i Atlas slips back into cosmic night, it leaves behind a sense of quiet wonder, an awareness that something vast has brushed against our world, leaving no harm, no warning, no signal, only the soft impression of a presence older than memory. The telescopes dim, the control rooms grow still, the data once a torrent becomes a trickle, then a gentle fade into archival silence. The object is gone, but the feeling it left behind is not. It lingers like a slowly settling mist, inviting reflection rather than fear. Whatever 3i Atlas was natural or constructed, chaotic or intentional, it carried with it the calm dignity of something shaped across aeons, shaped by forces we do not yet understand. Its coherence was not threatening. Its patterns were not aggressive. Even its strange reconfiguration near the sun felt less like an alarm and more like the slow turning of a page in a book too old for us to decipher. Perhaps that is all it ever meant to be, a reminder that the universe holds stories far older than our questions. Stories told in the language of rotation and chemistry, of thermal breath and cosmic scars of endurance through the coldest places and the brightest stars. As we return to our small world, its thin air, its warm oceans, its fragile life, the mystery of 3i Atlas becomes not a puzzle to solve, but a gentle reassurance. If the cosmos can hold such ancient order, such delicate resilience, then perhaps it is not as empty as it seems. Perhaps it is full of memory, full of remnants, full of echoes drifting silently between the suns. And as we close our eyes tonight, somewhere out there, far beyond the last whisper of sunlight, a solitary object continues its patient rotation, carrying with it a secret that may never be spoken yet forever, soft in its presence. Sweet dreams!